the question. So first thing is to draw x and y axis mutually perpendicular, and the next step is to write velocities and acceleration along x and y axis. So let me show you an example. This is a projectile. I am projecting a ball with a velocity u initially, which is making theta with the x-axis. So let me assume this to be u cos theta, which is the velocity along x direction. This is our x-axis and this is our y-axis. According to the first step, x and y-axis are mutually perpendicular to each other. So it's the u cos theta in the x direction and u sin theta in the y direction. It's easier to remember the angle, the theta which is nearer to the the line which is near to the theta is the cos component, and which is away from the theta is the sine component, and the ball follows a parabolic path like this. And talking about the accelerations, as mentioned in the second step, is to write velocities and accelerations in x and y axis. So in y axis the velocity is u sin theta, and talking about the acceleration in the x direction is 0, as the velocity in the x direction remains constant, because cos theta doesn't change, right? Because in the x direction it follows the constant velocity. Acceleration along x direction is 0. Whereas talking about the y direction, acceleration in y direction is minus g. It's minus g because I'm projecting it against the gravity. Gravity will be acting downwards always, as we all know, but due to the projection against the gravity that it tries to pull down, so that's why it follows a parabolic path. Let me show a few examples related to this. So the one more example is, let me assume a horizontal projectile. So this is a building. I have projected something with a velocity u. So it will generally follow a parabolic path here as well. Let me assume it in the x direction we have ux, which is u only. It doesn't change in the x direction, and whereas in the uy it is 0, because I have projected nothing in the y direction. I have only projected in the x direction. Due to the horizontal projection it follows a parabolic path, and acceleration along the x direction is 0. Along the y direction we have g, because it's following in the direction of gravity, it falls down. Let me assume another case. This is an incline. This is alpha. So let us suppose the incline makes an angle alpha. What if I project a projectile from here like this? It follows a parabolic path here as well, which makes an angle theta. So I'll be resolving again in x and y direction. This is my x direction, this is my y direction. So again u cos theta along this, whatever I see, and u sin theta along the y direction. Let me write the velocity. Ux is u cos theta and uy is u sin theta. The next thing is, what about the accelerations? Acceleration is nothing but in the x direction. Let me assume a mass to be here. So it will be resolving into components. This is the normal. No, this won't be the normal. This is the normal. This will be helpful in Newton laws as well. Wait. Yeah. This is like this is like this, and this. If here it makes an alpha, so here as well we get an angle alpha. So the nearer to the alpha is, acceleration is g. It acts downwards initially in this direction. I resolve into components. This is g cos alpha. This is g sin alpha. So acceleration along x direction is minus g sin alpha. Since we assumed x direction to be this side, it goes in the negative direction of x. so it's minus g sine alpha, and y direction is assumed over here, so along y direction we have minus g cos alpha, right? So let me show you some derivations involving in the projectile motion. Wait. So the first derivation is to find the time of flight. So basically, what is time of flight? It's the time taken to, reach a projectile. Overall time taken coming from this part to this part is the time taken from reaching here, following by a parabolic path. So here Sy is 0 from the third point we have, and I'll be using the equation here. Sy is equal to, wait a minute, Sy is equal to uy plus half ay t square, right? Now since Sy is 0, I will keep it as 0, and along the u direction we have u sin theta, as we have shown in the previous. Wait, let me show you again. In the previous case, this angle theta, velocity is u cos theta is my x component, and y component is u sin theta. One minute. So talking about the accelerations, along the x direction we have 0 acceleration, along the y direction we have negative g. I have explained in the previous part of this video, plus half minus g t square. This is equal to ut plus half a t square. Sorry, we'll be having one more t here. So y is equal to uy t plus half ay t square, right? So it will be u sin theta. Let me denote time of flight as capital T here. So again we'll be having 0 is equal to u sin theta into t plus minus half g capital T square. So I'll be sending over this side, over this again. Yeah, so u sin theta into capital T is equal to half g capital T square. The square gets cancelled. We get time of flight as 2u sin. So our time of flight is 2u sin theta by g. This is the derivation we had for time of flight. For the different cases you can derive this as well, for finding range or any other thing like maximum height reached.